Coordinate Geometry Introduction Exercise. The following is an exercise on the gradient, the midpoint and the length of a line. Pause the video at this point, have a go at the questions, and then when you're ready I'll go through the answers. Okay, in question 1 we have to find the gradient, the midpoint and the length of the line AB, where in section 1 A is equal to 1, 3 and B is equal to 7, 11. In part A, to find the gradient we're going to use the formula y2 minus y1 over x2 minus x1. Now we've got x1 is 1, y1 is 3, x2 is 7 and y2 is 11. So that gives us the gradient of AB is 11 minus 3 over 7 minus 1, which is 8 over 6, and it cancels down to give the gradient of AB equals 4 over 3. In part B, to find the midpoint, we're going to use the formula x1 plus x2 over 2, y1 plus y2 over 2. And using the same values as before, we have the midpoint of AB is 1 plus 7 over 2, 3 plus 11 over 2. Which is 8 over 2, 14 over 2, or the midpoint is 4, 7. In part C, to find the length of the line, we use the formula the square root of x2 minus x1 squared plus y2 minus y1 squared. And using the same values, we have the length of AB is equal to the square root of 7 minus 1 squared plus 11 minus 3 squared. Which is the square root of 6 squared plus 8 squared, or the square root of 36 plus 64, which is the square root of 100, and so the length of AB is 10. Now we can see what this looks like by drawing a graph. If we plot the point A and B, and then join them with a straight line, we can draw a horizontal line from A, and a vertical line from B to meet at a point, and we see that we've got a triangle with base 6 and height 8. That means the gradient of the line is 8 over 6, which is 4 over 3. We can see the midpoint. If we draw it in, we can see it has coordinates 4, 7. And if we use a ruler, we can measure the length of the line, and that's 10 centimetres. In question 1, part 2, we have A is equal to minus 7, 2, and B is equal to 5, 7. So to find the gradient of the line, we have x1 is minus 7, y1 is 2, x2 is 5, and y2 is 7. And we substitute it into the formula y2 minus y1 over x2 minus x1. So the gradient is 7 minus 2 over 5 take away minus 7, which is 5 over 12. To find the midpoint, we substitute the coordinates in the formula x1 plus x2 over 2 and y1 plus y2 over 2. And this gives us minus 7 plus 5 over 2 and 2 plus 7 over 2, which is minus 2 over 2, 9 over 2, and so the midpoint is minus 1, 4.5. And to get the length, using the length formula, we have AB is equal to the square root of 5 take away minus 7 all squared plus 7 minus 2 squared, which is the square root of 12 squared plus 5 squared, or the root of 144 plus 25, which is root 169, so the length of AB is 13. Again, we can see this in diagram. If we plot the point A at minus 7, 2 and B at 5, 7, we can join them with a line, draw a triangle underneath, and we see the base is 12, the height is 5, so the gradient is 5 over 12. We can spot the midpoint, that's minus 1, 4.5, and if we measure the line, we find that it comes out to be 13 units. In 1 part 3, we have A is equal to 4 minus 5, and b is equal to minus 2, 3. So we have x1 is 4, y1 is minus 5, x2 is minus 2, y2 is equal to 3. So using the gradient formula, we have the gradient of AB is 3 take away minus 5 over minus 2 take away 4, which is 8 over minus 6, or the gradient of AB is minus 4 over 3. For the midpoint, we have the midpoint of AB is equal to 4 add minus 2 all over 2, minus 5 plus 3 over 2, which simplifies to 2 over 2 minus 2 over 2, or 1 minus 1. And to find the length, we use the formula, the square root of x2 minus x1 all squared plus y2 minus y1 all squared, which is the square root of minus 2 take away 4 all squared plus 3 take away minus 5 all squared, which is the root of minus 6 squared plus 8 squared, or the root of 36 plus 64, which is the root of 100, which means the length AB is equal to 10. And we can see this in a diagram. If we mark the coordinates 4, minus 5 and minus 2, 3, we can draw the line AB. We can draw a triangle underneath it. We see the base is 6 and the height is 8. That means the gradient is 8 over 6, but the slope is downhill, so the gradient is minus 8 over 6, which is minus 4 over 3. We can spot the midpoint, that's 1 minus 1, and we can measure the length of the line, and we see that it is 10 units. In part 1.4, we have A is 13, 1, and B is minus 2, minus 7. So x1 is 13, y1 is 1, x2 is minus 2, y2 is minus 7. And if we substitute in the gradient formula, we get the gradient of AB is equal to minus 7 take away 1 over minus 2 take away 13, which is minus 8 over minus 15, and so the gradient is 8 over 15. If we use the midpoint formula, we get the midpoint is 13 plus minus 2 all over 2, and 1 plus minus 7 over 2, which works out to be 11 over 2 minus 6 over 2, or the midpoint of AB is equal to 5.5 minus 3. To find the length of AB, we have x1 is 13, y1 is 1, x2 is minus 2, y2 is minus 7. We have the length of AB is equal to the square root of minus 2 take away 13 all squared plus minus 7 take away 1 all squared, which is the root of minus 15 squared plus minus 8 squared, which is the root of 225 plus 64, or the root of 289, which is exactly 17. Now we can see this in a diagram. If we mark the points A and B and draw a triangle underneath, we see the height is 8 and the base is 15, and so the gradient is 8 over 15. We can see the midpoint, that's 5.5 minus 3, and if we measure the length of the line with a ruler, we find that the length is exactly 17 centimetres. In question 1, part 5, we have A is 5 minus 2 and B is 11, 14. So x1 is 5, y1 is minus 2, x2 is 11 and y2 is 14. So the gradient is 14 take away minus 2 over 11 minus 5. So the gradient is 16 over 6, which cancels to give the gradient is 8 over 3. Now the midpoint is x1 plus x2 over 2, y1 plus y2 over 2, which gives 5 plus 11 over 2 and minus 2 plus 14 over 2, which is 16 over 2, 12 over 2, or the midpoint is 8, 6. And to work out the length, we use the formula, which gives the square root of 11 minus 5 all squared plus 14 take away minus 2 all squared, which is the square root of 6 squared plus 16 squared, which is the root of 36 plus 256, or the root of 292. Well, that works out on a calculator to be about 17.088. Now we can draw a diagram, mark the 2 points A and B, and draw a triangle underneath. And we see the sides are 16 and 6. Now that gives us the gradient is 16 over 6, or 8 over 3. And we can spot the midpoint, that's 8, 6. Finally, we can measure the length of the line with a ruler, and that comes to about 17.1 centimetres. Now in question 2, we have to find the point C on the y-axis that is equidistant from the points A, which is 5, 3, and B, which is 7, 7. Now to do this, let the point C be 0A. If it's on the y-axis, then the x-coordinate will be 0. So using the length formula for AC, we have x1 is 5, y1 is 3, x2 is 0, and y2 is a, and that gives AC is the root of 0 minus 5 all squared plus a minus 3 all squared, which simplifies to the square root of 25 plus a squared minus 6a plus 9, or the square root of a squared minus 6a plus 34. Now if we get the length of BC, we've got x1 is 7, y1 is 7, x2 is 0, and y2 is a. So the length of BC is the square root of 0 minus 7 all squared plus a minus 7 all squared, which is the square root of 49 plus a squared minus 14a plus 7 squared, which simplifies to the square root of a squared minus 14a plus 98. Now we're told that C is equidistant from A and B, so that means AC is equal to BC. So if we equate those two results and square it, we get a squared minus 6a plus 34 is equal to a squared minus 14a plus 98. Now the a squareds cancel, and that leaves us with 8a equals 64, or a is equal to 8. So our answer is the coordinates of C are 0, 8. Now we can solve the same problem using geometry. If we take a graph and mark the points A and B, join them with a line, and then draw the perpendicular bisector of that line. We place the compass at A, open the compass to slightly longer than half the length of the line AB, and draw an arc crossing the line. Then, using the same setting, we place the compass needle at B and draw an arc to intersect the first arc at 2 points. If we draw a line through those 2 points, this will be the perpendicular bisector, and any point on that line will be equidistant from A and B. We want the point on that line that lies on the y-axis, and that is the point 0, 8. So we have C is equal to 0, 8. In question 3, we're given 2 points, the point A, which has coordinates A3, and the point B, which has coordinates 9B. We're told the midpoint of these two is C, which has coordinates 6, minus 1, and we're asked to find the value of A and the value of B. Well, to solve this, we can use the midpoint formula, which is the coordinates are x1 plus x2 over 2 and y1 plus y2 over 2. We have x1 is A, y1 is 3, x2 is 9, y2 is B. So the midpoint is A plus 9 over 2, 3 plus B over 2, and this is equal to 6 minus 1. Now that gives us a plus 9 over 2 is equal to 6. And if we double both sides, that gives us a plus 9 equals 12. Subtract 9 and we get a is equal to 3. If we look at the y coordinates, 3 plus b over 2 is equal to minus 1. So 3 plus b is equal to minus 2. If we subtract 3, b is equal to minus 5. So our answer is a is equal to 3 and b is equal to minus 5. Now it's a little bit harder to do this on the graph, but if we draw a graph, we can draw in the point A. Now since we don't know the x-coordinate, we only know the y-coordinate as 3, it's actually somewhere on the line y is equal to 3. And the b-coordinate is somewhere on the line x is equal to 9. We now need to mark C, which has coordinates 6, minus 1. If we find the intersection of those two lines and call it D, and then draw a line from D to the midpoint C, C has to be equidistant from the 2 points on the lines. Well, the best way to do that is extend the line DC by the same amount again to E. Draw a rectangle by drawing a horizontal and vertical line from E. And then, where those lines cross the two lines y equals 3 and x equals 9, mark those 2 points as F and G. Now, because FG is a diagonal of the rectangle, that means C is the midpoint of the line FG. So F and G are the points we want. And so that gives us in F, A is equal to 3, and in G, B is equal to minus 5. In question 4, we're told a triangle ABC has vertices A, which is 2, 9, B, which is minus 2, 6, and C, which is 10, minus 10. We first have to find the gradients of AB and BC. So using the gradient formula for AB, we have x1 is equal to 2, y1 is equal to 9, x2 is equal to minus 2, and y2 is equal to 6. This gives the gradient of AB as 6 minus 9 over minus 2 take away 2, which is minus 3 over minus 4, or the gradient of AB is 3/4. The gradient of BC can be calculated with x1 equal minus 2, y1 equals 6, and x2 equals 10, y2 equals minus 10. So the gradient is minus 10 take away 6 over 10 take away minus 2, which is minus 16 over 12, which is minus 4 over 3. Now in part 2 we have to prove the angle ABC is a right angle. Well, if we take the gradient of AB and we multiply it with the gradient of BC, we get 3 over 4 times minus 4 over 3, which cancels to minus 1. And if the two gradients multiply to make minus 1, it means the lines are perpendicular. So the angle ABC is a right angle. In part 3, it says calculate the lengths of AB, BC and AC, and hence show that AB squared plus BC squared equals AC squared. Well, AB is the square root of 2 take away minus 2 all squared plus 9 take away 6 all squared, which is the root of 4 squared plus 3 squared, or the root of 16 plus 9, which is root 25, or 5. For BC, the length is the root of 10 take away minus 2 all squared plus minus 10 take away 6 all squared, which is the root of 12 squared plus minus 16 squared, which is the root of 144 plus 256, or the root of 400, which is 20. Now the length of AC is the square root of 10 minus 2 all squared plus minus 10 minus 9 all squared, which is the root of 8 squared plus minus 19 squared, which is the root of 64 plus 361, or the root of 425, which equals about 20.62. Now, if we look at AB squared plus BC squared, that's 5 squared plus 20 squared, which is 25 plus 400, which is 425. Now that's equal to AC squared. So we have AB squared plus BC squared equals AC squared. Now if we draw a diagram and mark the points A, B and C, we can draw a triangle underneath AB and see that the height is 3, the base is 4, so that gives the gradient is 3 over 4. If we draw a triangle under the line BC, we can see the height is 4 and the base is 3, but it's going downhill, so the gradient is minus 4 over 3. And if we measure the angle ABC, we see that it's 90 degrees. In question 5, we have A as the point 1, 2. B lies on the line y equals 7x minus 30, and AB is equal to 5 centimeters. We have to find the possible coordinates of B. Well, to solve this, let B have coordinates x, y. So that means the distance between 1, 2 and xy is equal to 5. So the square root of x minus 1 all squared plus y minus 2 all squared is equal to 5. If we square both sides, we have x minus 1 all squared plus y minus 2 all squared is equal to 25. But we also know that B lies on the line, so that means y equals 7x minus 30. So if we substitute that into the equation, we get x minus 1 squared plus 7x minus 30 minus 2 all squared is equal to 25, which gives us x minus 1 squared plus 7x minus 32 all squared is equal to 25. And if we expand the brackets, we get x squared minus 2x plus 1 plus 49x squared minus 448x plus 1024 is equal to 25. Now this simplifies to 50x squared minus 450x plus 1025 equals 25, or 50x squared minus 450x plus 1000 equals 0. Well, we can divide all the way through by 50 to give x squared minus 9x plus 20 is equal to 0, which factorizes as x minus 4 into x minus 5 equals 0. Now, since two things multiply to make 0, one of them must be 0. So x minus 4 is 0, or x minus 5 is 0, which means x is 4 or x is 5. Now, if x equals 4, then y is equal to 7 times 4 minus 30, which is 28 minus 30, or minus 2. If x equals 5, then y equals 7 times 5 minus 30, which is 35 minus 30, or 5. So we have B is either the point 4 minus 2, or the point 5, 5. We could also solve this problem by drawing a graph. So if we draw some axes, mark in the point A at 1, 2, and draw the line y equals 7x minus 30, we want a point on the line which is 5 units away from A. So if we place the compass point at A, open it 5 squares, and draw an arc to cross the line at 2 points, we see it crosses the line at the point 4 minus 2, or at the point 5, 5, which is the same answers as before. In question 6, the triangle ABC has coordinates A, 5, 3, B, 14, 1, and C, 11, minus 4. In the first part, we have to find the midpoint D of the line BC. Well, to do this, x1 is 14, y1 is 1, x2 is 11, and y2 is minus 4. And we can substitute that in the midpoint formula. So the midpoint of BC is 14 plus 11 over 2, 1 plus minus 4 over 2, which is equal to 25 over 2 minus 3 over 2, and so the midpoint is 12.5 minus 1.5. In part 2, we have to find the gradient of CB. Well, using the gradient formula, we have x1 is equal to 11, y1 is equal to minus 4, x2 is equal to 14, and y2 is equal to 1. So the gradient is 1 take away minus 4 over 14 take away 11, and that gives us the gradient of CB is 5 over 3. In part 3, we have to find the gradient of AD. Now we use the gradient formula again, but this time x1 is 5, y1 is 3, x2 is 12.5, and y2 is minus 1.5. So the gradient is minus 1.5 minus 3 over 12.5 take away 5, which gives us minus 4.5 over 7.5, or if we double it top and bottom, minus 9 over 15, which cancels to give the gradient of AD equals minus 3 over 5. Now we want to show that AD is perpendicular to BC, so the gradient of AD times the gradient of BC we have as minus 3 over 5 times 5 over 3, which is equal to minus 1, and so AD is perpendicular to BC. We can demonstrate that on the graph simply by drawing the triangle ABC, then doing a geometry construction to bisect the line BC. We place the compass at one end, draw an arc slightly longer than half the length of the line, then place the compass point at the other end and draw an equal arc to intersect the first arc at 2 points. We notice that if we draw that line, it goes through the midpoint of BC, and it actually also passes through the point A. So that means the perpendicular line passes through A, and so AD is perpendicular to BC. But we can also check it with a protractor. We can measure the angle CDA and see that it is 90 degrees.